Assalamualaikum warahmatullahi wabarakatuh. So we are from Group 3. We're going to present you about our biomimicry project. Next one. So here are our group's name. First of all, my name is Muhammad Rian Pratama with my partner TENGKU MUKASYAF, NATHANAEL, GRIFFIN, and RAFI EWALDO. So here's my section that I will present you about what is biomimicry and some little about our innovation. So, what is biomimicry? Biomimicry is an approach that involves drawing inspiration from nature's designs, patterns, and strategies to solve human problems. The term biomimicry is derived from the Greek words bios or bios, meaning life, and mimesis, meaning to imitate. So, here are two examples of biomimicry that we know. The first of all is high-speed trains were modeled after the streamlined beak of the kingfisher bird to reduce noise and increase efficiency. So here we can take a look of a comparison of the biomimicry. You can see now the next example is the invention of Velcro was inspired by the hook-like structures found on birds that attach to animal fur. Here you can see the comparison of the biomimicry of animal and real life. So now let's go to the innovation. So basically our innovation that we innovate to create an unmanned drone that functions as a service to deliver package items or food with certain condition and has a better efficiency than online motorcycle like Gojek, Grab, taxi, especially very useful for people who live in high-rise buildings or apartment, so they don't need to go downstairs to take the food or the package. So we have inspired by three things from our biomimicry. The first is the innovation of ancient humans who wants to create in the future that postmen deliver goods or package or items not by their foot, lands, or using bike, but by using wings like an airplane, so they fly to our home to deliver our package. We implemented that into unmanned drones, so it's not by people but it's by drone. The next thing that we inspire from are whales. You know that whales have wings that function to facilitate maneuvering. Details will be explained in the next chapter by TENGKU ARYA. We implemented it to be the power that helps the drone propeller to fly and reducing some turbulence. The last one, we inspired by octopus, duck. You know that octopus has many hands and tentacles, so we want to implement it to be a cloud that transports the package or the item or the food to be shipped and then it goes to delivered by unnamed drone. Next, the topic is some new innovation that we want to add to existing tools beside the unmanned drone. So basically, we want to create the self-healing materials that is inspired by the regeneration ability of living tissues. The development of materials that can heal themselves when damaged is an exciting innovation. This could be building materials, fabrics, or even packaging material that are able to repair themselves after sustaining minor damage. The next is mechanism of action in the animal that we inspire from. This topic will present by TENGKU ARYA MUKASYAF. Thank you.
Thank you so much, Rian. Now, before we continue about my topic, let us talk about the animals that Rian taught us. Uh, we thought about some unique things this animal can possess, and we questioned, like how is the octopus able to capture its prey in water, and how is a whale, the size of a species, the size of a bus or bigger, agile in water regardless of the size, right? So let's start with an octopus. How an octopus, how the way the octopus holds an object in water is, regardless of its shape and size, is unique because it can hold onto those objects and it's going to be really efficient also holding it. And we found out that in the tentacles there are these small suction, how I say, suction cups, and these suction cups is basically subdivided into two: the infundibulum and the acetobulum. And let's start with the acetobulum. Acetobulum is basically the part that connects the infundibulum to the tentacles. also acts as a messenger between those two. And the infibulum is the main part of how an octopus is able to grip to its, how you say, uh, up to able to grip the object it's gripping. The infibulum is made out of a very soft tissue. The tissue is really soft, so almost as soft as a jellyfish. And this tissue and this softness is actually a major contributor of how it's able to grip so well. The softness and the microstructure of the, how you say, groove is the critical factor of how it's able to hold onto an object regardless of its shape and size and roughness, you know. And yeah, that's the main working of how an octopus is able to hold onto an object, you know. And the next one is the whales. Let's start. You know, there are a lot of there's a lot of whales, but we're gonna take humpback whale as an example for today. Humpback whale is one of the biggest mammals on Earth, and how can these animals be so agile in water? How are they able to go deep and also be moving? You know, like uh, 90 degrees in thousands of pressure and thousands of, you know, like water pressure and so on. And the secret of these, how you say, agility is its fins, mainly the front fins. The front fin of the humpback whale consists of a tubercle. This tubercle helps it move the water current into a specific direction that increase the lift while also decrease the drag, making it able to move, you know, like sharp turns that even fighter jets can't in air. And yeah, that's all for me. We have taken these examples and we have created an object that is supposed to be a pioneer, but this object is going to be further explained by Nathan Griffin. Thank you.
Hello, and today we will be showing you the model for our biomimicry project. So, as you can see here, we are using the biomimicry of a whale's fin for the wings, and we also use the suckers for from the octopus tentacles for the claws to carry an object. So this drone, the reason it has this modeled after a whale's fin is because whale's fin, this will reduce drag and also, wait, no, this will reduce turbulence when this drone is flying. That way it could be faster. And also this can be rotated. You can see this can be rotated. So when we are about to take off, the wing will look like, sorry. When we're about to take off, when the drone's about to take off, the wing will look like this. It'll be positioned like this, and then after it takes off, it will then look like this. It will just fly, and this will be the claws to carry an object. It could be any kind of object. For example, here I have pretend this is a box or a package. A box or a package. These parts are taken from tentacles of octopuses. These are suckers. That way, not only is this object not broken by the claw, it is also stuck to it because this rubber part is used to make sure that the object is stuck to the claw and not let go. Also, it's also a soft part that avoids the object from being destroyed by the claw. So yeah, that's it.
Hello, my name is RAFI EWALDO, and today I will be explaining the plus and minus of our products. So, the plus of our products is efficiency boost. The system excels in efficiency, streamlining process for quicker and more effective operations. Faster response time, rapid delivery. With an unmanned approach, the system ensures swift and prompt deliveries, contributing to time savings. The system also have an unmanned drone. The absence of human involvement enhances safety and reduces the need for constant monitoring. Direct rooftop delivery, or easier to deliver, is facilitating a direct delivery to a rooftops eliminates the necessity for ground level handling, simplifying the logistics. For the second one, we have the minuses of our product. The first one is the weight of the cargo can be more than 5 kilograms. So, the weight limitations, the system imposes a maximum weight limit of 5 kilograms for transported items, potentially limiting its application for heavier cargo. Second one is if the range is out of reach, it needs additional costs to prolong the needed range. So, over extended distances, the system might require additional resources to maintain its optimal performance. And the last one, it's dependent on the weather. It also needs protection and the added maintenance. Adverse weather conditions such as rain or snow can impact the system, necessitating supplementary measures for maintenance and operational adjustments. So for the reference, me, RAFI EWALDO, will be explaining the first reference, which is the Octopus-like Suction Cups from Natural to Artificial Solutions journal. The researchers aim to investigate the importance of surface morphology in artificial suction cups during wet attachment conditions. They replicated the morphology of the infundibulum of the octopus sucker in artificial devices and tested the influence of different parameters on attachment performance. The results showed that engraving the surface of the suction cups enhanced their attachment performance compared to smooth versions. The best performing suction cups had a surface geometry similar to that of an octopus suckers, with a max number and width of grooves and the smallest groove depth. However, it was noted that the artificial suction cups may require a larger groove width for better performance compared to natural suckers. The study also compared the performance of suction cups made from different materials. Suction cups produced by EcoFlex 0030 showed the highest improvement in detachment force compared to the smooth version, while suction cups produced with EcoFlex 0050 showed behavior equivalent to those produced with EcoFlex 030. Suction cups produced with Dragon Skin 10 showed comparable detachment forces for the different surface geometry tested. Overall, the results indicated that the engraving enhances the attachment performance of elastromatic suction cups, with greater improvements observed for suction cups made from softer materials. The researchers concluded that the surface morphology of suction cups plays a crucial role in their attachment performance. The best surface morphology for artificial suction cups was found to be the one most similar to octopus suckers, with radial grooves increasing in the area subjected to pressure reduction during the attachment. The study provides valuable insight for the design of artificial suction cups with higher wet attachment performance. That is all from me.
So the inspiration for the wings on our drone project is actually inspired by the tuber cells on humpback whales. It's Flipper's application of bio-inspired technology. This is one of our reference. So the humpback whale is exceptional among the large baleen whales in its ability to undertake acrobatic maneuvers to catch prey. Humpback whales utilize extremely mobile wings like flippers for banking and turning. Large rounded tubercles, along with the leading edge of the flipper, are morphological structures that are unique in nature. The tubercles on the leading edge act as a passive flow control device that improve the performance and maneuverability of flipper. Experimental analysis of finite wing models has demonstrated that the presence of tubercles produce a delay in angle of attack until stall, thereby increasing maximum lift and decreasing drag. Possible fluid dynamic mechanisms for improved performance include delay of stall to generations of a vortex and modification of the boundary layer, and increase in effective span by reducing both span-wise flow and strength of the tip vortex. The tubercles provide a bio-inspired design that was commercial viability for wing-like structures, control of passive flow, and it has the advantage of eliminating complex, costly maintenance and heavy control mechanisms, while improving performance or lifting bodies in air and water. The tubercles on the leading edge can be applied to the design of the watercraft and aircraft, translation fans and windmills, and also the project of the drone that we are making. Not only does it work on water, it also works on air to decrease drag and increase lift. Thank you.